Stripping cable components. Overlap the cable ends by approximately 150 mm and mark the reference line in the center of the overlap. Carefully cut the cables at the reference line and ensure that the ends butt squarely. Thoroughly clean the cable outer sheath on both ends for an appropriate distance to accommodate the nesting of the outer tubes. Carefully slide the outer tubes, dual extrusion tubing, and hose clamps over the cleaned cable ends. Cut and remove the outer sheath and armoring on both ends in accordance with the dimensions indicated in the installation instructions. If a Burma bedding sheath is present, cut and remove it carefully. In the conventional manner, cut and remove the lead sheath on both cable ends to the specified dimensions. Always ensure that the lead sheath cutback exhibits a bell-shaped profile and take special care not to damage the underlying components during the stripping process. The conventional stripping precautions following the removal of the lead sheath on screen paper insulated power cables are slightly different from those of the belted type cable. Carefully unwind the copper woven fabric tape on both cable ends. Rewind the copper woven fabric tape around the crutch of both cable ends at a point 20 mm from the edge of the lead sheath cutback. Cut and remove the core fillers. Tie a binder or position a constant force spring around the metallized screening papers on each core. Carefully unwind and remove the screening papers on each core by tearing them against the edge of the binders. Cut a 50 mm piece of yellow mastic void filler tape at a 45-degree angle. Place the point of this tape overlapping the metallized paper screening by 10 mm. Tension the tape to half of its original width. Apply 4 to 5 half-lapped layers in the same direction of lay as the metallized screening papers. This tape must be applied to overlap the metallized screening and the paper insulation by 10 mm each. Repeat the process on all the remaining cores. Slide and position the clear tubing over both long and short cores to a point approximately 50 mm from the crutch on both sides. Using the same precautionary measures as with screen paper cables, start the stripping process of belted cables in a similar manner. Slide and position the clear tubing over both long and short cores to a point approximately 50 mm from the crutch. Adjust the gas torch to obtain a low intensity soft blue flame with a yellow tip and shrink the clear tubing down nearest the crutch for a distance of approximately 50 mm. Twist the clear tubing on both sides in the same direction of lay as the underlying paper insulation and at the same time push it as far as possible into the crutch. Using the same flame intensity and starting in the crutch area, shrink the clear tubing into position simultaneously on each set of cores. Ensure that the clear tubing is shrunk down evenly and is free from air or grease pockets. Connecting the conductors. Mechanical torque shear conductors have for many years been the standard components for some low voltage distribution cable jointing systems in many parts of Europe and America. The most recent and most beneficial step forward in mechanical connector development has been the introduction of the range-taking connectors. Mark the insulation surface at the end of each core at a point equal to half the length of the connector plus 5 mm. At the mark, make a cut around the circumference of the insulation. Take special care not to nick or cut into the conductor strands. In the event of sector-shaped conductors, round them off by using a pair of gas pliers or a conductor shaping tool. Carefully remove the insulation at the end of each core. Position the 3 red connector insulating tubes to nest on the longer cores. Insert the rounded conductors into the connectors. Ensure that the opposing conductors butt squarely and that a 5 mm gap is maintained between the edges of the connectors and the insulation on each core. Nip tighten the shear bolts moderately by hand and once again ensure that the dimensional parameters are visibly evident. Position the connector holding tool correctly around the connector and activate the locking mechanism. Ensure that the connector is located tightly inside the cradle section of the holding tool. Start the tightening process preferably in the center and torque each bolt in turn progressively little by little until they shear off. Repeat the process in the remaining connectors. Thoroughly check and ensure that there are no sharp outward pointing protrusions left on the surface of the connectors. Should there be any such protrusions evident, they can easily be removed by using a file followed by buffing with a strip of fine grit aluminium oxide abrasive cloth. Material application. Material development is a continuous process that more than often combines a series of scientific principles. Skillful manipulation of material properties have made new products with vastly improved material application techniques possible. All these materials, however well processed, are only as good as the level of skill at which they are applied. It is important to understand that immaterial of what type of connectors are used in medium to high voltage joints, the connectors must always be overwrapped with a void filling medium. This is done primarily in order to eliminate all ionizable air voids over the irregular surface of the connector, as well as the interface between the connector and the subsequently applied stress control mechanism and primary insulation. Using the yellow void filling tape and stretching it to approximately half of its original width, apply it over the gaps on both sides of the connector. Build it up gradually to a point level with the edge of the connector on either side. Continue to apply the void filler over the length of the connector and overlap the insulation on both sides by not more than 5 mm. The final diameter should be slightly greater than the core or the connector diameter, whichever is larger. Slide the red insulating tube centrally over the connector. Adjust the gas torch to obtain a moderate intensity blue flame with a yellow tip. Starting in the center, shrink all 3 tubes into position at the same time by rotating the flame. Keep moving the flame continuously to avoid scorching the material. Ensure that all 3 tubes are completely shrunk down. Lubricate the cores inside the crutch. Insert the yellow mastic void filling wedges into the crutch on both sides of the joint. Push the wedges carefully into the crutch using an insertion device or a suitable tool. Partial extrusion of the yellow void filling mastic between the cores are an indication that the wedges are properly inserted. Remove the release papers from the core separator. Insert and centralize it between the red core insulating tubes. Squeeze the cores firmly together and ensure that the red insulating tubes are in contact with the mastic of the core separator profile. Remove the previously applied binders over the belt papers. Remove the release papers from the strips of black mastic filler tape. Position the tape along the joint at each end of the red insulating tube so that it overlaps the clear and red tubing. Apply 1 turn around the circumference of the joint at each position by stretching it to half of its original width. Starting at a point 10 mm over the lead sheath, apply the yellow void filler tape in successive highly stretched level wound half lapped layers. Continue to apply it over the cores up to a point in line with the black filler profiles. Build it up to a cone-like smooth profile. Starting on the clean lead sheath adjacent to the yellow void filler tape, apply 1/2 lap layer of red mastic environmental sealing tape extending for a distance of 50 mm over the lead sheath on both sides of the joint. Lubricate the surface of the joint with a thin constant layer of cable lubricating grease. Take care to apply it sparingly. Slide and position the black and brown dual extruded inner joint tubing centrally over the length of the joint. Ensure that the inner ends of this tube is clean and free from foreign residue. Shrink the dual extrusion tube into place by starting the shrinking process in the center and working towards the ends. Keep moving the flame in a circumferential motion to prevent scorching of the material. Applying the earth continuity. The lead sheath in paper insulated cables provide both earth continuity and mechanical protection. Thus, applying the earth continuity effectively over a joint is an extremely important consideration. It not only safeguards the system against damaging effects of earth fault conditions, but also contributes a great deal to human safety. Cut and remove a section of the outer sheath on both sides for a distance of 100 mm to expose the armoring. Using an effective method, thoroughly clean and degrease the surface of the exposed lead sheath on both sides. Starting on the one side first, apply one layer of thin copper mesh tape around the exposed clean lead sheath. Position the tinned copper earth braid over the joint. Apply 2 full turns of the constant force spring over the tinned copper earth braid and the tinned copper mesh tape. Fold the tinned copper earth braid back over the constant force spring. Apply another turn of the constant force spring. Fold the braid back once more and apply the rest of the spring. Tighten the constant force spring with a firm twisting action. Repeat this procedure on the opposite side of the joint. It is important to understand that the application of the copper mesh tape around the lead sheaths are done in order to ensure an effective all-round equal connection around the circumference of the lead sheath. In addition, the folding back of the tinned copper braid has been proved to enhance the long-term short-circuit reliability of the design. Secure the ends of the tinned copper earth braid in electrical contact with the armoring on both sides by using the hose clamps provided. A banded strap may also be used for this purpose. Cover the sharp edges of the constant force springs and the hose clamps by applying a layer of black mastic tape around the circumference. PVC adhesive tape may also be used for this purpose. Apply outer protection and environmental sealing. Starting at a point 30 mm over the cable outer sheath on the one side, apply the galvanized steel screening mesh tightly in half-lap layers over the length of the joint to a similar point on the opposite end. Continue applying the screening mesh until the roll is finished. The outer protection of a cable joint can be effectively installed in many ways. The ultimate objective of the application is to ensure a protective covering which will provide the necessary protection of the joint against mechanical abuse. It must also prevent moisture ingress and resistance to harmful chemicals, while at the same time possess maximum aging characteristics. The Raychem compound fill joint has been specifically developed to possess all these important characteristics, as well as the added advantage of being lightweight and easy to construct. The screening mesh provides maximum mechanical protection as well as an effective electrical screening mechanism. Tie it off with a PVC adhesive tape or a half hitch. Carefully clean, abrade and flame treat the cable outer sheath on both sides of the joint for a distance of approximately 200 mm. Position the first outer sealing tube over the one side of the joint, overlapping the outer sheath by approximately 150 mm. Shrink it in place by starting from the outer sheath and working towards the center of the joint. In the same manner, position the second outer sealing tube over the joint on the opposite side and shrink it into place. It is highly recommended that the finished joint should not be moved or backfilled until it has cooled down substantially.